Hello and welcome to my second training, part of the project management e-learning program that I am leading. Some of you asked the question on how should you build your network diagram in order to identify your critical path of the project. So in this respect, today's training is about showing you the best way of building the network diagram. On the agenda, we would attack today the ways of building your work breakdown structure, followed by building your network diagram. After building your network diagram, we will focus on how should we identify, calculate, and manage our critical path. Okay, the best way of learning is by playing. So let's presume that today's project is building this nice black car that can reach a speed of 700 kilometers per hour in just 10 seconds. Scope of the project is already defined in more details, so let's go and see what working packages can we get out of this. In order to build this nice car, we should focus on building the interior parts of the car along with the exterior parts. If we are talking about the interior parts, we are of course talking about the seats, the steering wheel, and of course the engine. If we are talking about the exterior parts, we are talking about the wheels, we are talking about the doors and the windows, and we are talking about the front end of the car. So if we would divide this in smaller packages, the front end of the car is formed by the bar and the lights, along with the plate number. Okay, we should give code for this in order to be easily managed in the future network diagram. So let's put A, B, C, or you can put anything that you would desire in order to help you build the next of the project. So these are the working packages that we will be focusing on today. And the process of building those working packages is called the PMI work breakdown structure methodology. Okay, as part of the time management, let's see the activity list. So first of all, we should build a list of activities like the one presented here. We should have on the first column the name of the activity, on the second column setting activity, and on the last column the estimated duration for each activity in case nothing bad happens. Okay, we would work on the following structure. So in the middle of our box we will have the name of the activity. We will start with the early start time of this package. We will continue with the early finish time. Of course, the late start time and the late finish time. Okay, so let's get started. This is our starting point. The first activity is the one highlighted here. Okay, so we should build the packages for these two activities. Activity E and activity I. So these activities are the first one in the list, so they will start point 0, so they will start in day 1 of the project. We should now look at the estimated time for this activity. If you take a look in the table, you will see that the estimated time is 3. So we will just write 3 here. This means we need 3 days to finish this activity. So if we add 3 to 0, we will get 3. So this means that after the end of day 3, we should of course have the activity finished. Let's do the same with the other activity package. So we will put 0 here, so the early start will be 0. This means that it will start at day 1. 6 is the estimated days needed to finish this activity. So we will just write 6 here. Of course, 0 plus 6 equals 6. Let's go to the other activity. In this case, we should look at the fact that preceded by E and I. So the two activities that we already listed down here. So in this respect, these two activities should be finished before activity G starts. So we will put activity G here, and now we have to decide if we would start in day 3 when the first activity ends, or if we will start in day 6 when the second activity ends. So again, 3 or 6. The idea is getting the biggest number. Why? Because we need both activities to be finished. In day number 3, the only activity that is finished is this one. In day number 6, both activities are finished. So in this respect, we will put 6 here. Again, we should identify from the table the estimated date, so 2. So we will put this in the top of our working package. So 6 plus 2 is 8. In this respect, activity G will start after the finish of day 6 and it has to finish in day 8. Let's go to the other one. Again, the activity D is related with activity E and I. In this respect, we have to choose again between 3 and 6. So before activity D can get started, we should assure that the two activities that are listed before it will end. So again, the same thing, activity D will start after day 6. Why? Because 6 is greater than 3. Again, we need 1 day to finish this activity, so we will list this in the top of the activity box. 6 plus 1 equals 7. Let's go to the other one. Activity C will come after activity D. So this is a simple one. We will just list activity C here. It has to start after activity D is finished. So we will just copy the early finish date of D into the early start date of C. Again, we have 6 days to finish this activity. So 7 plus 6 equals 13. Let's go to activity A, that comes right after activity C. So in order that activity A to be able to start, we have to have activity C finished. So again, if activity C is finishing in day 13, then activity A should start after day 13. So we are just copying 13 from here to here. Again, we are looking at the table. We have 2 days needed to finish this activity. So 13 plus 2 equals 15. Let's go to activity B that comes right after activity C. On the same principle, we will list here activity B. If activity C ends in the end of day 13, then activity B should start after the activity before it ends. So we are just copying 13 here. Again, let's look in the table. Estimated date for activity B is 1, plus the 1 day needed for finishing this activity. It's 14 days till activity B should be finished. So in this respect, let's just go to the last column of our table and we will see that activity G, A and B will end the process. This means that we will just combine the 3 activities into the end of the process. Now we should identify how long this process takes. So we have 8 days, 15 days or 14 days. So just look here, 8, 15 or 14. So the longest period is 15 days, so the project is taking exactly 15 days to finish if everything goes according to plan. A very nice trick of building this is making the boxing proportionally with the length of the estimated days. So as you can see here, because this is the longest path, we don't have to validate these things. We know that this is the last one. If you look here at the G, we see that this can't be the ending of the project because it still takes this distance here. Okay, let's go to the other part. So how should we identify the critical path? If you are using this method that I have showed you, then it's very simple. The longest box structures will be the critical path. If not, then you should calculate. So we have 3 plus 2, that equals 5. We have on the other path 6 plus 1 plus 6 plus 2, again equaling 15. And we have on the third path, so we have 6, 1, 6, and we come here to 1, totally equals with 14. So in this respect, the critical path, the longest activity sequence. Why is this called the critical path? The critical path cannot be delayed. Any activity on the critical path that is delayed will harm the project end time. We should pay a very big attention to the critical path activities. So we should focus on the critical path activities always when we manage our project. In that case, we are coloring the critical path into red just to make sure that we know this. Okay, because the activities cannot suffer delays, the late finish date should be equal with the early finish date. So we have 15 and 15, we have 13 and 13, we have 7 and 7, we have 7 and 7 again here, we have 6 and 6, we have again 6 and 6, and we have 0 and 0. Okay, this was the easy part. The critical path has always the early start equals with the late start and the early finish equals with the late finish. Okay, let's see how should calculate the other paths. Project B ends at day 14, but the project ends at day 15. So in this respect, this can be easily delayed with 1 day without harming the project. So we are just copying 15 here. We are taking into consideration the estimated time, so it's 1 in the top of the page, and we make the difference. So in this respect, 15 minus 1 equals 14, and 14 is here. So 14 is the late start date for this activity package. Let's see the other one. So again, we are copying 15 here, again, and we will have 13 here. How did we calculate this? Exactly as for the previous example, it's 15 minus 2 here equals 13. So how should we interpret this? So activity G, for example, can start after day 6 and end at day 8, or it can start at day 13 and 8 at date 15 without harming the project. So let's go to activity E. Activity E is related with activity G and activity D. So the activity G late start time is 13 and the activity D late start time is 6. In this case, because we are going into the opposite direction, we should compare 13 with 6. And we should put here 6 because 6 is the smallest one. Again, we are talking about 3 days here. So 6 minus 3 equals 3. So dear friends, this is how you are building a network diagram, the critical path, and how should you manage your project. So please keep in mind this trick that I have developed. So in order to make a visual thing as well as the mathematical calculations, you can do the difference between the boxes of each activity based on the estimated time. The estimated time for this one is 3 and the estimated time for this one is 6. So in this respect, this one will be bigger. If we are doing it like this, we don't have to make a lot of calculation because the longest path is pretty much the critical path. If this training was helpful, don't miss the other ones that are coming soon. So just follow me on YouTube, contact me via these 2 email addresses, or follow me on Facebook. Thank you for your attention.